So let's do some lidocaine math. We know that a dose of lidocaine is 1 to 4 milligrams per minute. Now let's say you've been ordered to give 2 milligrams per minute to your patient, and we want to know how many drops per minute that's going to be. So whatever our unknown is, let's just begin with that at the beginning. So we need to solve drops per minute. So we always want drops to be on our top, and we'll start with our drip set because we know that that's going to give us our unit of drops. So a 60 drop set is 60 drops in 1 milliliter. So now we know that in this equation we don't want milliliters. We want to try to rule this out. So next we're going to put in something over here to figure out how to get rid of our milliliters. So we need milliliters on the top. We need to figure out what concentration and everything we got that can rule that out. So if we look, the concentration of lidocaine is 4 milligrams per milliliter. So in 1 milliliter, there's 4 milligrams of lidocaine. Now, our units will cross out. So our milliliters have canceled out. Now, we need something up here with milligrams to cancel out milligrams. So we know that our dose is 2 milligrams per minute. Now, we can cross out our milligrams. And if we look, we are left with the units of drops and minutes. So now we can solve the math. So this would be 60 times 2 over 1 times 4 times 1, so over 4. Then we can break it down even further to 120 over 4. That's 120 drops in 4 minutes based on our units that were still left here. So breaking that down, that would be 30 drops per single minute. Now we'll move on and do dopamine. So the dose of dopamine, 2 to 20 micrograms per kilogram per minute. And we're going to say we've been ordered to give 5 micrograms per kilogram per minute. And let's say our patient weighs 100 kilos, just to make this demonstration of math a little bit easier. Okay, so we know the 5 milligrams per kilogram at 100 kilograms. We'll break down that math first to get our dose. So we know 5 times our 100 is 500 micrograms. So that patient's going to need a total of 500 micrograms over 1 minute. And now we know that we need to solve for how many drops per minute that's going to be. So again, we'll go with our 60 drop set. So 60 drops equals 1 milliliter. And we know that we need to get rid of milliliters. So something on the top here to get rid of milliliters. And if we look at our concentration, we'll see that our concentration is 1600 micrograms per milliliter. So in 1 milliliter, there's 1600 micrograms. Always pay attention to these concentrations that you're going by the same dosing. So we've got micrograms from the concentration because we need to give micrograms. If not, you're going to have to do your conversion, which you could put into this at the beginning, but make sure you just are always with your same concentrations. So now we need to put micrograms on the top to get rid of that. So we've already ruled out 1 micrograms, and what do we have left? Yes, our dose. So we need to give 500 micrograms over 1 minute. And again, our micrograms is canceled out. And now we're left with drops on the top and minute on the bottom. Well, that's what we need. So now we can solve for math. So we can do 60 times 500 over 1600. And to break it down a little bit easier without breaking out the calculator and punching in a bunch of zeros, we can cancel out our zeros. So one from the top, one from the bottom. Another from the top, another from the bottom. Okay, so then we break that down, we're left with 60 times 5. So you're 300 over 16. So break it down one step more. So you take your 300, divide by 16, and that gives you 18.75. Remember that we had those units of drops per minute. So now we broke it down and we're going to give 18.75 drops per minute. Okay, moving on, let's do we have a concentration. We need to figure out how many milliliters we're going to bolus this patient. So what we need to do is start with our desired dose over our on-hand dose times our volume. So if we're to have been ordered to give 2 milligrams of Versed, we're going to put our 2 over our on-hand dose. That is, if you look at the concentration of this vial here, there's 5 milligrams in 5 ml. So we're going to put that our on-hand dose is 5 times our volume of 5. So when we break that all down, 2 divided by 5, remember, do that first. 2 divided by 5 times 5 is going to give us 2 milliliters. And even breaking this down before, if this is milligrams over milligrams, this is your mLs, these units cancel out, so we're left with 2 milliliters of what we would need. Let's do that one more time. Let's say we're ordered 4 milligrams this time. So we give this a quick erase here. Okay, so we're ordered to give 4 milligrams this time. Our desired dose is 4 milligrams over our on-hand dose of 5 milligrams times our 5 milliliters. So when we break down that math, 4 divided by 5 is 0.8 times our 5. You break that down, and now you need to give 4 milliliters of that medicine to give them 4 milligrams, which, using this example, is pretty easy since your concentration of 5 milligrams and 5 milliliters is 1 to 1. So however many milligrams you need is going to equal that same amount of whatever milligrams you need is going to equal how many milliliters you need to give. Final example here, say we need to give some fluid to this patient. Say we're just going to give us a seemingly KVO rate in order to give fluid at 20 milliliters per hour. Now we need to know how many drops per minute that's going to be. So again, we're going to start out with our drip set. So we do, not 60, but our 10 drop set. So 10 drops equals 1 milliliter. And again, we need to get rid of our milliliters here. So we'll go with our order of 20 milliliters per 1 hour. Again, our units of milliliters will cancel out, and we're left with drops per hour. Well, that's not what we want. We need drops per minute. So we need to get rid of this hour. So 1 hour equals 60 minutes. So now we can cancel this unit out. So we're left with 10 times 20 being 200 over 60. Now all we need to do is do our math of 200 divided by 60 of our drops per minute. So that breaks on down to 3.3 drops per minute. So if we're given 3.3 drops per minute, if we want to know about however many seconds that is, we know there's 60 seconds in 1 minute, so we can take that 60, divide by that about 3, and that's going to give us approximately 1 drop every 20 seconds.